Okay, so we're going to do two examples in this video. That's right, two examples in this video. And we're going to take this, now it's translated parabola, because we have some sort of shift here and some sort of shift here. Got to be careful with these guys because it's set up a little different than the previous shapes. We're going to put all the junk that we need to put in there, the vertex, the focus, directrix. Okay, so here's where we need to be careful. When the guy is in parentheses with a square outside of it, then we know it's going to be a -1 in the y direction. Now this guy right here, this is a bit, we generally don't see it like that. So here's what I like to do. I like to, well, I'm going to shrink this down first, and we'll zoom in when we graph. But what I like to do is I like to get this guy on the other side. Okay, and so, hey, wait a second. If all the other junk was gone, so if all, I'm going to erase this, but let's say all this other stuff was gone, x would just equal 3, right? Well, then that's what x is equal to. X is equal to 3. So the idea is, if you understand that we need to get it equal to the variable and have the variable by itself, then we know what the shift is. So for it to be, I'm cleaning all this up here. Okay, sorry, yeah, taking a little time here, but you guys get the idea, right? Okay, clean it up. So now, the idea is set this guy equal to 0 and solve. Set this guy equal to 0 and solve. X is by itself, y is by itself. So what that means is if I had this on the other side, is the x by itself, so it's the +3. And so that's what we need to understand. So with the parabolas, it's a little bit different than the other shapes, and sometimes kids get confused as to, well, is it a positive, is it a negative, which one is it? So you want to say, okay, well, if I isolate the variable, what's my solution? So the variable's not isolated, so I got to move the 3 over. It would make it positive. Bam, +3. It's already isolated. It's +3. We're good to go. Okay, so now to get the vertex, we already have that. We know our vertex is going to be 3, -1. And I know for our focus and directrix, I need this guy P. Okay, so I know P comes from our standard equation where I have x is equal to 1 over 4p y squared, right? So whatever coefficient we have in front of the y, so if we look at this guy right here, that's going to give us our p-value. So I'm going to go ahead and work with that right now. So I'm going to set it up. Most of you might be saying, well, Mr. Thornley, it's 3, right? So we know it's 3. So I know p is equal to 3. And p is the distance from the vertex to both the focus and the directrix. One's just going in one direction, one's going in the other. So algebraically, I know how this guy opens. It's an x is equal to, so I'm going to open right and left. So technically, I could take this vertex and I can add and subtract 3, and I'm going to get what I need, right? I'm going to get my focus. I'm going to get my, point for directrix that I can draw a vertical line through. So the idea is I just need to shift those units. And I think a picture is just so much easier with these problems. So I'm going to go ahead and zoom in here. And I know that the vertex is at 3, -1. So I'm going to go ahead and plot 3, -1. And I know P is equal to 3. And it was an x is equal to equation. So I'm going to open to the right. Okay? It was positive, so I know I'm going to open to the right. So I'm going to draw my parabola opening to the right from the vertex, and I'm going to count 3 units. And counting 3 units is not too hard. We'll change this guy to green. I'm going to go 1, 2, 3. So then that means I'm going to plot my point right here, this is my focus. It's on the inside. So my focus is at 6, -1. I shifted 3 units. Okay? My directrix, remember, is going to be an equation of a line. And it's an x equal to equation, so it's going to be an x is equal to directrix. And in order to find the directrix, I just move 1, 2, 3 units back. I'm going to go ahead and plot a point here, and that just gives me a reference to where I should be drawing my line. And I got this dashed red line right where x is equal to 0. So I have my focus and my directrix, and I have my vertex. P was equal to 3, and I use that as to find the information that's required. Okay, so on to our next. So in our next example, same thing, but the difference here is we should look and identify right. Oh, this is a y equal 2. So this guy, I know right away, is gonna open up or down. I got a negative in front, so I know this guy is going to open down. So first thing I'm going to do is I'm going to go ahead and shrink this guy. And so we got a little bit of space to work. And then once again, we will zoom in for our graph. So I'm going to do the vertex real quick. So I got this guy right here. Is that y all by its lonesome? No. So I'm going to say y plus 3 is equal to 0. Y is equal to -3. And I'm going to take this guy, it's not all by itself, set it equal to 0. Y is equal to -2. So I know my vertex is at -2, -3. And I know I'm going to open up. Excuse me, I know I'm going to open down. So my vertex is here, and I open down. So my focus is going to go down from here. Well, how do I find the focus? I need to take this fraction. I'm going to ignore the negative, and I'm just going to take this fraction. 1 over 6 is equal to 1 over 4p. It's not as straightforward as before. Maybe it is for some of you. Maybe you see 3 halves. Maybe you don't. I don't know. But I'm going to go ahead and I'm going to cross multiply. And I get 4p is equal to 6, and p is equal to 6/4, which reduces to 3 halves. So p is equal to 3 halves. Okay? So I'm going to go ahead and I'm going to zoom in. I'm going to use the 3 halves to kind of work with what we have here. Okay? So knowing where the vertex is and knowing how it opens. Okay? So we don't have any more information. So let me go ahead and do this. I want to double check. Yeah, -2, -3. So I got -2, -3, and this is my vertex, and I know P is equal to 3 halves. So I'm going to plot -3, -2, and it was negative, so we open down, okay? And because P is 3 halves, I'm going to move 1.5 units back. Well, you should be able to look at the graph. One, we should know that this is the directrix because it's behind the parabola. And notice I'm really using the picture to get the information that I need. So my y is changing. So my directrix should all pretty much be able to look at that graph and say that's y is equal to -1/2. Well, what's 1.5 plus -2? -1/2. How about my focus? I got to move inside the parabola, right? So I'm going to move 1.5. So that's -3.5. Okay? So I know with my focus, if I'm going to have -3.5, and that should give us, so we're still at -3 for the x, right? Notice how that didn't change. Okay, so the x doesn't change, it's the y that changes. And that's going to be a negative, let me get to my pen here, -7 halves, not thirds, halves. So I have my directrix, my focus, my vertex, and my lovely graph. And that's how we graph parabolas, translated parabolas. Same ideas as our other shapes, but the parabola is slightly different than what we've already talked about. So that makes it a little bit more confusing, but shifting, we're always moving from the center. The vertex is really the center now. Okay?